Instead of waiting till tomorrow in class, let's pick it up right here. We have 3x squared plus 2x minus 10 equals 0. Start off by plugging this into quadratic formula, and then press play, and we'll see if we can get to the same end result. Hopefully you can get to this point, and I stopped here because of the 124 on the inside. As I started plugging things into quadratic formula, I noticed that the c value was negative. And as I did b squared minus 4ac, you have 4 minus, and then on the inside, 4 times 3 times negative 10 is negative 120. That means those two negatives cancel out and change to positive. That's how you get 124 on the inside. Now that isn't a perfect square, but there's a number that goes into 124 that is a perfect square. So we can break this down into 4 times 31. And when you do that, you'll be able to simplify the 4 times 31 all over 6. The square root of 4 is a perfect square, so we can go to the outside as a 2. This gives us, I know this problem's kind of crazy, this gives us 2 plus or minus 2 radical 31 all over 6. That's a plus right there. Oh, my pen's being goofy today. So 2 plus or minus 2 radical 31 all over 6. Now look at the number in front of the plus or minus, the number right after, and the number at the bottom. We can reduce this fraction if all three of those numbers have a common factor. And they do. 2 goes into all three of those numbers. 2 would go into itself once, into the other 2 once, and into 6 3 times. What this means for us is our exact solution will be that 1 plus or minus 1 square root 31 all over 3. For some reason, my pluses and minuses aren't showing up very well, so let's make sure we get that clear. We have, well, maybe not. There we go. Hey, better. 1 plus or minus the square root of 31 over 3. Those are the exact solutions for x. If you wanted to know the approximate, you'd plug them in to your calculator. All right, I'm going to put you to the test on this last one. 2x squared minus 5x plus 5 is equal to 0. See if you can simplify completely using quadratic formula. For our final problem, we end up getting a negative on the inside of the square root. If you plug in the b squared minus 4ac, negative 5 squared would be positive 25, but 4ac is 40. And when you subtract, we get a negative on the inside of the radical. That's not a valid solution. We can't evaluate the square root of a negative number. What this means for our quadratic equation is there are no real solutions. And that's another option for solving quadratics.